Hi everyone, I welcome you all in the quick solution discussion of All India Akash Test Series Medical 2020. And I'm here with the test number 7, code C and D. Let us begin with the chemistry section of this paper, where the first question is question number 46. Volume occupied by 1 mole water. Its density is also given, that's 1 gram per centimeter cube. It means in this case you need to just find out volume. What's the relation between density and volume? Density is mass per unit volume. It means volume is equal to mass upon density. In this case, density is given, that's clearly given here in the question. That's 1 gram per centimeter cube. And one more thing, you have 1 mole of water. And what would be the mass of 1 mole of water? That is equal to the molar mass of water. What's that? That's 18 gram per mole. It means mass of 1 mole of water is equal to, you have mass, you have density. You can find out volume. That's equal to 18 upon 1 gram per centimeter cube. It means it was 18 gram. It is 1 gram per centimeter cube. And that would be equal to 18 centimeter cube. And we know that 18 centimeter cube is equal to 18 ml, because 1 centimeter cube is 1 ml, that's why. So what would be the volume of this? It is 18 ml. Where it's given? It's given here in option 2. So easily you can choose option 2 as the correct answer for this question. Yes, it's a turn for next question. Question number 47. Maximum number of orbitals in a subshell of an atom is determined by. In this question, you need to just find out the maximum number of orbitals which are present in a subshell. If I talk about S subshell, there are only 1 suborbital. If I talk about P subshell, 3 orbitals are present there. What is the correct formula to find out the maximum number of orbitals with the help of azimuthal quantum number? In this question it is asked, because the values are given in terms of L value. L is azimuthal quantum number, we know that. And yes, exactly you can answer this. Maximum number of orbitals in a subshell equal to 2L plus 1. And on the basis of this, correct answer becomes option 1 for this question. After that, there's another question. Question number 48. If uncertainty in position is twice the uncertainty in momentum, then uncertainty in velocity is. It means what you are going to do here, you are just going to consider that uncertainty in position is twice the uncertainty in momentum. This is the exact fact that you need to just follow here. We know that the product of delta x and delta p, what is that? X is uncertainty in position and delta p is uncertainty in momentum. That is always greater than or equal to h by 4 pi. Which rule it is? It is Heisenberg uncertainty principle, we know that. And in this particular question, it is said that delta x is twice the delta p, clearly given in the question. So instead of writing delta x, if we use the term 2 delta p, then we can correctly find out the answer of this question. So simply we know that delta x is 2 delta p. Delta p is already there. That is equal to, we are assuming it is equal to h by 4 pi. Now, we can write it, delta p is equals to h by, this 2 comes here, it becomes 8 pi, and here was delta p squared, so I'll mark here a root. And this delta p has this value. Now, we know that delta p is m delta v. That is equal to root h by 8 pi. So what would be the value of this delta v? It is equal to 1 by m root h upon 8 pi. This is the correct relation on the basis of Heisenberg uncertainty principle. And if it is so, where this answer is given, this uncertainty in velocity is correctly given here in option 2. So just choose option 2 for this question as the correct option. After this, question number 49. Which of the following ions is largest in size? We have different ions here. There's a lithium ion, there's sodium ion here, magnesium ion we have Mg2+, and aluminium ion. If I talk about lithium, lithium has atomic number 3. Its configuration is 1s2, 2s1. It means if one electron is lost, its configuration becomes 1s2 for the lithium ion. If I talk about sodium, the electronic configuration is 1s2, 2s2 and 2p6. This would be the configuration for this sodium ion. Similarly, if I talk about magnesium ion, the configuration would be same for this also, because total 12 electrons are there in case of magnesium atom. If it is Mg2+, so there are total 10 electrons. So this is the configuration, and the similar configuration is there for aluminium also. It means this lithium is the smallest in size, so it cannot be the correct option. So I'm just leaving this Li plus ion. Now if I talk about these species, in all of them there are the equal number of electrons. These are isoelectronic species, and in such case we can consider the size with the help of nuclear charge present on them. If I talk about sodium ion, 1 positive charge is there, while in case of magnesium ion there are 2 positive charges, and in case of aluminium ion there is 3 positive charges. Maximum nuclear charge is there with aluminium. That's why among all these species, in these isoelectronic species, the smallest size is there with aluminium ion. Due to the more nuclear charge, the size of its ion is comparatively smaller. If I talk about Mg2+, size is slightly bigger. And if I talk about sodium positive ion, Na positive ion, that has the largest size. So definitely in this case, the answer is this sodium ion, which has the largest ionic size, and on this basis I'll choose this as the correct option. Let's take question number 50. Electron deficient species among the following is. We have different options given here. What are electron deficient species? These are generally Lewis acid, which have the deficiency of electron. If I talk about the option 2, CH4, methane, this is electron precise species. While if I talk about H2O, this is electron rich species. It is not electron deficient. For the same case is there for the PCl3 also. But if I talk about this BOH3, this is boric acid. Boron atom is here, and in this way 3 OH groups are attached, and in this case this boron is electron deficient. This is electron deficient. Why? Because it is the member of group 13, and in this compound it does not have the completed octet on this boron. That's why it is electron deficient species. So option 1 becomes the correct option for this question. Let's take next question.